Hi guys, welcome back to my YouTube channel. In this video we are going to see about half-life from radioactivity topic. I have included a few IGCSE physics past paper questions from half-life and answers with my explanation. Let's start. Half-life of a particular isotope. It is the time taken for half the nuclei of that isotope in any sample to decay. In other words, half-life is the time taken by any radioactive source or isotope to become half. This is the formula for half-life. In this video, I am going to explain without using this formula. You must be also familiar with this decay curve and the instrument or device used to detect any type of radiation. This is called GM tube, and here is the meter called rate meter or count meter. Let's start. Points to remember before solving half-life questions. Always read the question carefully and underline the key points. Keep checking whether the question includes any background radiation. Most of the half-life questions are based on half-life of particular source, not the half-life of the background source. Remember, count meter always shows the reading of the source with background, if any. So, before calculating half-life, always subtract the background reading from the given reading. After calculating half-life, again read the question whether they have asked only the half-life of the source or reading shown on the count meter. If reading shown on the count meter, then after finding half-life by subtracting the background, you have to add the background reading. So let's try a few questions. So you can pause the video, try the question by yourself, then play for explanation. Let's start. Try this question. Let's discuss the answer. So the question is, what is the count rate due to radiation from the radioactive source? Here you can see before placing the radioactive source, there is some count. This is background radiation. Then after placing the radioactive source, this is the new count reading. So in the question they have asked only the count rate due to the radioactive source. So you have to subtract 200 minus this background radiation. So 192 is the answer. Try this question. Let's discuss what is the count rate due to the source after 8 days. In the question they have given the half-life of 8 days. It means after 8 days the radioactive source become half. That is, we have to divide by 2. But here this count rate is with background. So before dividing into half, we have to subtract the background. So this 180 is only the counts for this radioactive source. Now we can divide by 2. We are doing only once because in the question they have asked to find after 8 days. So we can divide it by 2 only once. So the answer is B. Try this challenging question. Let's discuss what is the background radiation count rate. Here is a half-life of 15 hours and the background count rate has not been subtracted from these data. It means these data are with background. We have a clue in this table, that is 30 hours. So the half-life is 15 hours. So 15 times 2 equal 30. It means from here to here it become 2 times half. So with the values given, we are going to check with each values whether we are getting this 115 after two halves by subtracting the background and adding the background finally. Let's do. So initially 400 minus background, that is 388. So it must become 2 times half. So 388 divided by 2 equal 194. Again divided by 2 equal 97. And again we have to add with background. It is 109, not 115. So repeat these steps with all the values and check. We get C, that is 400 minus 20 equal 380 divided by 2 equal 190 divided by 2 equal 95. Again we have to add with the background, that is 95 plus 20 equal 115. So after two halves with background we get 115 value. So the background is 20, that is C. Try this question. Let's discuss what is the measured count rate after a time of one half life. In this question, the detector is in a laboratory with no shielding from background radiation. It means this count rate is with background. So we have to add these both and divide by 2. So the answer is D. Try this question. Let's discuss what is the half-life of the isotope. Initial count is 38,000. After one half, it will become 19,000. So that 19,000 count will be in between 1 and 2 here. It means it will be more than 1 year and less than 2 years. So the answer is B. Try this question. Let's discuss what is the half-life of the source. Here this initial and final counts are with background. So we have to subtract background from both and we have to find how many times this 512 become half to reach 64. So 1, 2 and 3. So 3 times it becomes half to reach 64 and it takes overall 12 hours. Then for one half life equal 12 divided by 3, that is 4 hours. The answer is C. Try this question. Let's discuss what is the half-life of the source. Here the initial count rate is 2000. Half of that 2000 is 1000. For 1000 the corresponding time is 1 hour. Then half of 1000 is 500. The corresponding time for 500 is 2 hours. So the half-life is 1 hour. For each 1 hour the count become half. So the answer is B. Try this question. Let's discuss how many atomic nuclei have decayed after 60 days. So here they have asked how much is decayed. So first we will find how much is left after becoming half. Then we will subtract that from this initial value. Before that, let's find how many 20s are there in 60. There are 3. So 3 times it become half. So here is a calculation: 1 time half, 2 time half and 3 time half. So the balance is this much value. But the question is how much have decayed. So we have to subtract from the initial value. This minus this, we get 7 times 10 to the power 10. So the answer is D. Try this question. Let's discuss What is the count rate 10 minutes later? So the count rate will be always with background, and here they have given the background is 20 counts per minute. But while doing half-life, we have to subtract this background. So initial count is 1000 minus background, it is 980. The half-life is 10 minutes, and they have asked what is the count rate after 10 minutes. It means one time it become half, and the count rate meter will always show with background. So add again the background, then the reading will be 510 counts per minute, that is C. Try this question. Let's discuss what is the reading on the detector 1.5 hours later. The half-life is 0.5 hours. So how many 0.5 hours are there in 1.5 hours? That is 3. So the value will be 3 times halved. So here 1 time, 2 time, then 3 times. So the value will be 750 counts per second. That is A. Try this question. Let's discuss how long will it take for the rate of emission to fall to 32 counts per minute. So initially 128 counts per minute, and it falls to 32 counts per minute. So let's find how many times it become half. So from 128 to 32, it becomes 2 times half. For each time it takes 4 days. So total 4 times 2 days, that is 8 days. Answer is C. Try this question. Let's discuss what is the half-life of the source. Here initially the number of emissions per second is 800. So half of 800 is 400. So from 0 to 20 minutes it takes to become half from 800 to 400. Let's check again. 400 to 200. Again it takes 20 minutes. Then 200 to 100. Again 20 minutes. So the half-life of the source is 20 minutes. Try this question. Let's discuss what mass of this isotope remains after 10 days. So the half-life is 5 days. So two fives are there. So 2 times it become half from the initial amount. That is 1 time, 2 time. So the answer is C, 100 mg. Try this last question. Let's discuss what is the half-life of the source. The initial count is 1600, and it has fallen to 100 counts, and the whole time is 32 hours. So let's find first how many times this one become half to reach 100. So here 1, 2, 3 and 4 times it become 100. For that 4 times it takes 32 hours. So we have to find for 1 half how much, that is 32 divided by 4 equal 8 hours. So the answer is C. I hope you got some knowledge about half-life. Thank you for watching. Wish you all the best.